Hello and welcome to part 15. And today I decided to give it a shot trying to implement simple self-collision detection. And the reason why I say simple is because I honestly is not really satisfied with the way I figured this out. So it was kind of a dilemma for me to broadcast this because I'm really not satisfied with it. But I actually hope that somebody is watching this and maybe can come up with a better idea for this. So here we go. First of all, let's turn off the leaf and turn off the randomization so it doesn't jump around too much. Okay. And in order to get some self-collision, we need to make these longer, I think. So let's give them like 8 maybe. And let's take down the segments. I guess we don't need that many. Just need a few to begin with. So now we can see some of these are crisscrossing over each other. And that's kind of the point here. So what I'm looking to do here is to make sure that whenever one of these intersect with one another, then it should see if it can adjust the top one to go over the bottom one. But since I don't have any notion of which went there first, really I do kind of, but that's I guess it's up to the way that the branches are generated. I'm gonna have to rely on that. So if we open up, I gotta apologize for the background noise. There's still a lot of construction work going on outside. So now and then there's gonna be a little bit of noise. So gonna have to live with that. Inside the render tree, we have this section where we drag out the location start and the start tangent. And we actually also need the end position. And while we're at it, we might as well also just save out the end tangent. So let's promote these two to local variables. So this is a int. And this is the end tangent. So we've got to make a little bit more space here. Okay. So actually I guess I need quite a lot more space. So let's move this to the side here. Because I'm gonna shoot in a line trace in between all this. And what I'm gonna do is to start off by rewiring these start position. So we don't have that long line, those long lines. And end. And end tangent. Oops. All right. And I probably, I'm gonna shoot in a line trace here. Something like this. And with these line traces, I always run out of space. So actually what I'm gonna do straight away is to collapse this to collapse nodes and call this trace self collision trace. like that. And what this is going to do is to update these variables. So, one of them, to be specific, I'm only going to be adjusting the end because, yeah, this is the way I'm going to implement it in this episode here. So maybe later on I will change that if I figure out a better way to do it. But for now, I'm going to use that. So if we jump back to the generate tree, no, not the generate tree, where is it? The generate render tree. Then we have these positions here, and they come out in local space in my case here. So I need, in order to do a line trace, I need to convert this to wallspace. And I'm gonna drag this one out, and we're gonna drag this one out. Okay, and then we're gonna get active transform, and from this one we're gonna drag out transform location. Notice you have a local location and direction. If you transform a direction, then it's the direction of the vector. But if you transform a location, it's going to transform it into wallspace, given a local transform, or location. Just nice to know the difference between these two. Can't really explain it other than what I just said. Let's see. So now we have a begin and an end, or start and end. So let's just hook this up for now. I can already tell there's going to be a problem with this, but let's just do it for now. And then we gotta make a branch here. And hook that one up. And yes. So the logic I'm going to be implementing is if we hit something along the way, then we are going to adjust it according to the normal of the endpoint, I think. Yeah. So the endpoint, they each of the points here, they have a rotation, but we don't have the rotation. We only have vectors here. But if we remember from the generate render tree, from here, we have an array of transforms. So we actually do have access to the rotations. So the trick here is really to get that transform instead also. And I just happen to have access to the local transforms here, so I can just write in get. And I also, in the beginning, why did I do that here? In my for loop, I saved a copy of the index. So I have access to this in the local segment index. So this is going to give me the full transform. So here I have my rotation, and you need to drag that to the other side here, I guess. And from here on, the idea is to pull that a distance out relative to the up vector of that rotation. So yeah, I hope this makes sense. So it's, if this is a curve, then it's gonna be pointing outwards here. That's the way I built it in the generate branch. If you remember the logic from trace forward and trace down, and you remember I did some adjustments, get surface transform and all that stuff, and that's going to make sure that it's going to adjust it in the right direction. However, this is only being set if we have collision with some existing geometry. So in case it's kind of freestanding, it's not going to be adjusting in the correct direction. Okay, so we can get the up vector here, and then we can multiply this by a certain amount. For now, I'm just gonna type in like 10, I think, maybe. And then we have the endpoint, local end. Put it up here, and then we can add that together with that offset. It's gonna offset it. And we only want to do this if we have a line trace hit. So that means that we're gonna set the local end. Like that. So in case it doesn't hit, we don't do anything. Right, so we can compile this and save. And we can see it pulled it inwards in this case here. Something is going on, but it didn't do anything up here as we expected. So we have a bug. And the thing is, I think to begin with, I traced the wrong, pulled it the wrong way. Need to minus this. So now it's getting pulled outwards. But it's getting pulled out at a weird position here, really, because it doesn't have any intersection. And it didn't pull out this one for some reason, which is kind of odd, I would say. Honestly, I'm not really sure why. But one thing I know for sure is that the reason, I'm pretty sure, is the reason that this is self-colliding with a branch. So it's not really working, or maybe it's colliding with the cylinder itself. So what I want to add to this is to say I don't want to ignore self to begin with. So that did something. Now we can see it's checking against itself. But we also have a lot of disconnected segments now. So we also want to make sure that whatever comes out of this hit, we can say is this ourself? We need it to be ourself, actually. So we have hit actor, it needs to be equal to self. So apart from being true, it also needs to be itself. I mean, apart from being hit, it needs to be itself. So if we compile this, then we see some of this disconnection got fixed. Not all of it. So we still have some work to do with this. I'm gonna try and make this as clean as possible, but it's actually kind of hard with this one. That's a little bit better. Okay, so I'm gonna do something like adding a trace instead of, because we're tracing on the visibility channel right now. I'm gonna go into settings and define a custom collision channel for this. So it's gonna be a trace channel. So make a new trace and call this, let's call it tree. And default set this to ignore and accept. And now we can close this one and open it again and say tree. Now we trace in the tree channel. So now nothing is happening. And all we need to do is to make sure that when we make our spline mesh, that it's going to be responding to that trace channel. So I'm going to make a new one here. Collision response to channel, and say tree. For this one should be block, I'd say. And to be honest, I don't know if there's any restrictions to where I need to put this. Where do I create it? Here I create it. I guess I can self-collision trace. So I don't want to, when I do my check, I don't want to self-collide with myself, this segment I'm building. So I think I'm going to put it afterwards and see if that makes a difference. I should spend some time commenting this, I believe. I mean, it's getting a little bit, it's just this one line with something with leaves at the end. If I read this in a week, I probably can't figure out what I did or why I did it. So at some point I will take some time to comment it, maybe in the next episode. So okay, so we have a fair amount of disconnection still. Now the thing is, when I do my adjustment to the end point, I still start at the same point. So that's kind of a problem. So I need to make sure that it stays the same. So I'm gonna be introducing a local adjusted variable, which I'm gonna be setting to true if I adjust it. And then I'm going to set it to false if I don't hit anything. And what we're also going to do in the render tree, when we get the start point, then normally we just get it from the get location and tangent at spline point, but if it was adjusted, then we want to get the endpoint actually. Like that. So if it was adjusted, we want to get the local end. Oops, wrong one. And if it wasn't adjusted, then we can safely just get it like this, and then we can set it here instead. That's kind of a mess now. Well, that's not going to be pretty anyway, I guess. You know what? I'm just going to leave it here. Okay, so now things got connected again. Some of it. So we still have a problem, and this didn't get fixed. So we need to do something else and take a look at the logic I'm building here, because obviously something is still wrong. So self-collision trace, I guess when we do make a hit, the thing is, if we are at the endpoint, then we don't want to adjust. I mean, if the endpoint is at the end of one of the branches, then it's going to adjust it. So if this is the last point in that branch, then the endpoint is going to be for the start point for the endpoint is going to be the beginning. They're going to be dragging it all the way up here. That was a shitty explanation. But anyway, I hope this is going to make sense in a moment. So what I really need to do here is also to make a check, an additional check. So yeah, as I said in the beginning, I guess this can be made in a probably better way than I'm doing it right now. But I can't really wrap my head around it, and I don't want to have this hanging over my head, so I'm just gonna do it. So we have the local segments per branch. I believe this is the number of branches. I'm just gonna check. It's this one, segments per branch, but we need -2 here, so I don't save that. That was unfortunate. Got -2 here also. That was actually kind of annoying. Why don't I have that? Okay, that's a point for optimization. I don't really need to do this for every segment. Oops. Okay. So if this is the local segment is less than, meaning it's not the end segment, then we can adjust it, and otherwise we'll just jump down here and say we didn't adjust it. And that means that it's going to pull the start point from the spline start point. So let's see what we get now. Got rid of the weird jumps. So we still have some stuff here we need to take care of, because it's not giving us what we want really. We actually have quite a few issues. Okay, so I'm gonna take a look at something here. If we consider this scenario here, we have a branch growing out that way, and we're gonna make a trace going from this point to approximately this point here. And that means that it's gonna start the trace inside an existing branch, which is gonna cause it to adjust that point. And that's why it's getting deformed like that. So what I'm going to do again is kind of a workaround for this, because I can't really figure out a better way to do it. So I'm going to take my start point and I'm going to hang on a sec. I'm going to take my endpoint and I'm going to subtract the start point. That's going to give the direction that I'm tracing. And then I'm going to normalize this so it becomes a 1 vector. And then I'm going to multiply this by the length of the segment itself. And I have that in the branch here. Branch length factor here. So that's currently set to 20. That means that it's gonna end up at the end point, but then I'm gonna divide this by 2. So it starts halfway up. Oops. So I'm not entirely sure, as I said. This is a good way to do it. I could do this in a number of ways, I guess, but let's see. If we compile this, save, we still have some issues. You know what? I think maybe I'm pulling this, either I'm pulling this the wrong way. Oh, I need to plus this with my start vector, of course. There we go. Okay, so it's not working entirely as I hoped. I mean, here, I really would have thought that would adjust it. And then again, it's adjusting the point here. That's weird. Okay, I think I have a bug somewhere, and I'm kind of in a hurry, so I can't really spend too much time debugging today. But I will definitely figure this out next time. Just wanted to get this out of the way. As you can see, this is kind of a chunk of stuff I'm adding, and I'm adding it to the render tree, so I have it inside this for loop here. So that means it's being executed for every segment along this path here, so it's quite a bunch of stuff, so I just added in. Yeah, so actually it's a good example of how to use the collapse graph, but it's also something to be aware of in this case. That is going to be kind of heavy on maybe on performance, but yeah, there's a lot of stuff here I just added in. I think I'm just gonna get rid of that one. Hey, I lost it. There we go. Better. Okay, let's see how much time I have in the video. So 26 minutes. Okay, I think I'm gonna take a break here and gonna continue later with a debugging session. And I also have this annoyingly snap-on issue that I talked about, I think, a few videos back, where it kind of, you can see it here in action, it's snapping into the wall. I kind of want to get rid of that and yeah, make it look a little bit better. I don't know why it's doing that weird wobbly thing. It's like it's detecting a collision to begin with anyway. It definitely is, but why? Hang on a sec. Take the end. Multiply by the length, divided by 2, add that to the start. That's going to be my start point. And all of this is happening in local space. Whoops. I guess it would help if I did a debug line here. See where it's tracing from. It's not tracing. To me it looks like it's not tracing from here, but it is in fact tracing from all the way in, so it's like that logic I just added is not working. Okay, one last thing. I'm gonna turn this off, and then I'm gonna take this and gonna connect that one up. I'm gonna do everything on the other side here, and I'm gonna say this minus this, normalize, multiply by, let's say, 10 plus start plus this offset. So this, yeah, okay, let's turn off for duration. Okay, now it's straightened it out. Okay, so why did it? Now nothing is hitting. Huh. Oh, or is it? Huh. Oh, this one is. Huh. I think it's working. Except this one is not working, or is it? No, it's self-intersecting. Maybe it's because it's too thin. Let me just try and adjust that. And sorry for the fumbling again. Those of you that have been watching me, you know I do this sometimes. So, kind of a trademark, I believe, at this point. Oh, it is actually deforming. But this one is not for some reason. I don't know why. Maybe it's something to do with the trace. It definitely looks like it would have intersected. And up here also. Okay, so there's a few issues here still. Okay, anyway, I'm gonna take a look at it off video and gonna get back to you with hopefully an explanation. And then I'm also gonna tackle this snapping thing. I have postponed that for way too long now. So stay tuned and be seeing you. Bye bye.